the point of selflessness to a degree that it's only.
I cried.
There's
I
a
cried.
really cute Nicholas Sparks
Yeah,
book,
no,
but,
no,
like,
no,
I didn't
no,
even hear from him on that.
His
And
wife
like
goes into a coma, and like
I don't care. I was
had like this
it's busy. I don't want him to put
It's like she never went into a coma, like that she didn't want him to suffer, so she wouldn't die.
That's what I'm doing. You quit what I'm
And
doing.
like he,
so busy though, because
like,
he wants.
she made him promise that he would, but
doesn't
everyone
want to
just
just
having
have
and she wakes up.
like he doesn't want to do that. He wants to actually.
You have to read the vow.
Because then otherwise we have this
No,
awkward
I don't
back
care
and
if
forth
you've
thing.
seen
Like
the
he
movie.
texts
The
me when
movie
I'm
is
at work,
nothing
I
like
text
the
him when
book.
I'm off,
You
and then
have
he
to
texts me in
read
the
the
morning.
book.
And then I would
It's
wake up and by the time I would
Literally, like every chapter, you end up like in tears. It's incredible.
So
It's
he'd rather just
incredible. You have to
he
read
he
this
doesn't he hates
husband's
texting when he's
devotion to
talking
his
on the
wife.
phone.
Me too.
It's
I've talked to her
ridiculous.
for
Yes,
this
and
morning,
just
it's like texting can only say
crazy.
so much. Like you can say like,
It's
oh,
ridiculous.
I saw a
She comes
pie.
back as like a completely different person.
Did you say
I saw a pie?
Yes. Like, I'm just saying, like,
I was like,
fucking
gay
shit.
shit from my
remember
picture. He's like,
eating
I like
it.
pie. I was like, that's more like it.
Okay, I'm done.
I love everybody except for you.
Now we're gonna be happy.
I was like,
May
right.
have been a blubbery idiot.
I think I liked that.
You did.
I think I did
You
too.
put- Oh my god.
I was like, oh my god, I love that.
My
Terry was like,
sent
what
flowers.
did you say? Your brother? Okay.
Sent flowers.
Excellent song choice. I was like,
Girlfriend, not girlfriend. Girl.
Hey, purple head.
Whatever.
Wait, Luke?
Yes.
Who?
Yesterday.
I feel like
Questions? Did we have homework last time?
No.
we
I-
had about 2 nights to go.
Asian park.
Yeah,
I had
but being
nightmares.
killed.
You had nightmares?
I talked to her, Mom, the ocean is really scary.
A whale could
Being
literally pee
whales
out
and
of you and
invasive
kill you.
species.
We're gonna die.
I forgot my book.
What if there were birds like that?
You forgot your book?
My book.
You'll be okay
What
with
if like
that.
every time someone gets pooped on by a bird, the bird is just sitting there and be like,
You stupid person.
Where's my homework?
Heck.
No.
we had homework turned in from like 2 days ago. Yeah, it's February 13th.
We must then. Okay, so before we get into the new lesson, what section is the homework from? 58? Okay, well that's,
I forgot about that.
right. Okay, we're good now. Yeah, that's right, I thought we had homework from 58. So, any questions from that homework assignment on section 58? Number 13? Number 13 says find the area of the triangle. Let's look at the picture. 80 degrees is the angle. 7 is the measure, 7 meters in particular. Of that diagonal and 10 meters at the base. Now, if you're going to find the area of a triangle, base times height divided by 2. We've got the base, all we need is the height. And the height is able to be gotten using that angle. Because when you draw in the height, you always draw in the height perpendicularly. When you include a perpendicular, now you have a mini triangle, it's a right triangle, where you can use sine, cosine, and tan. So, in particular, opposite and hypotenuse, sine. Sine of 80 degrees is equal to h over 7. So, when you multiply whatever sine of 80 degrees is times 7, that's going to give you the height. And it's probably going to be like 6.2 or something.
6.89.
6.89, so I was off by a few. 6.89, that's the height. And I think that makes sense. Notice that 80-degree opening is very large. So the difference in length between the height and that diagonal segment, pretty close, because you're almost at 90 degrees. If you were 90 degrees, you'd be straight up and down. The leg would be the height. But now, just multiply base times height divided by 2, and you'll get 68.9 divided by 2, which is 34.45 meters squared. So base times height divided by 2. Anything within a tenth of that is fine, it doesn't have to be exact. Any other questions from the homework from a couple days ago? Yes, no, maybe so? No, 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 I got no, no, no.
I got it.
So let's get ourselves into 57. Deal with sine and cosine graphs. But here we're going to be changing the period. Now, just to be clear here, when we talk about the period of a graph, okay, the period, this is the length of one cycle. Okay, so.
Weird, that sounds familiar to me.
No, yeah. This is a general term. Period is a general term to refer to the length of one cycle. To return, yeah. I'm thinking of
Die.
another example is a grandfather clock, right? The time it takes for the clock to go from one side, for the thing to come back to the other, back to the same side, that would be one cycle, and you could measure that period in a length of time. You can measure the period of a sine and cosine graph in terms of the length of the x-axis. I'm just telling you, this is...
You told us we had to be mentally ready for this lesson.
Yeah. Now ready? Okay. Now, let us remind ourselves. When you look at a graph of y equals sine x, sine starts at the origin, goes up, and eventually gets to the point where it's going to repeat again. But there is a portion of that graph where you go through one complete cycle. Notice how you're at the center line going up, and then later you're at the center line going up. You basically have recycled the graph. This length is the length of one cycle. This is the period of our sine graph. And in the case of our sine graph, what is the period? How long does it take for the sine graph to recycle? What is the point on the x-axis here where it recycles? 360. And remind me, why is it 360? Why is it 360? Why is it exactly the number of degrees in a circle? Because when you follow the sine, all you're really doing is following the y-coordinate on the unit circle. So the sine is positive, then the sine is negative, and back around again. Every time around the unit circle, you recycle. Why? Because you're back around the unit circle, doing the, at 390 degrees. You're at the same point as 30 degrees, and so on. Make sense? Cosine graph does the same thing. Because all the cosine graph is just monitoring the x-coordinate of the unit circle. So it starts positive, then goes negative, then comes back from the positives, and then recycles. That's all it's doing. And the cosine starts up here at 1, and it also goes down, and up, and reaches a point where it recycles again. Notice it reaches a point where it's at the top and going down. And that's the point where the graph is recycled. That's one full period. And what's the length of one cycle of a cosine graph? 360 degrees. Again, the period of both the sine and cosine graphs are 360 degrees. That's how we would measure. It's the length of one cycle, and the length of that cycle is measured on the x-axis. So you're at the top going down, later at the top going down, recycling. That's one cycle, that's 360 degrees. What if we put a number, though, in front of our x? Think for a second. At what value of x will we have gone all the way around the unit circle? Look at this graph. Here's the question. At what value of x will we have gone all the way around the unit circle, which is 360 degrees? What value of x is going to get us to sine of 360? See, when x equals 180, this gives us the sine of 360, which means we've gone all the way around the unit circle. So when you put that 2 in front of your angle, that's going to take you around the unit circle twice as fast. You only have to bring your x up to 180 for you to have gone all the way around the circle. Think in the normal case of y equals sine of x, you're going to have to bring that x up to 360 to go all the way around the circle. Here we only have to bring the x up to 180. What's that going to do to our graph? That's going to change the period. The graph's going to look almost exactly the same. It's going to still, sine of 0 will still be, well, when x is 0, you're still going to get the sine of 0. But the time it takes to recycle and start again will not be 360. It will be 180. Because as far as x is concerned, and that's your horizontal axis, an x of 180 gets you all the way around the unit circle. So an x of 180 is the period for this graph. Okay, let's think about this. Let's ask the same question with these graphs. What if we had y equals cosine of 3x? What x value is going to take us all the way around the unit circle? X equals what takes us all the way around the unit circle? X equals 120. X equals 120 will be all the way around the unit circle. So what does that mean for this cosine 3x graph? That means when we have the 3x, the period of our graph is only 120 degrees. It recycles more quickly because it shoots itself around the unit circle more quickly. You're zooming around the unit circle at 3 times the pace. So every 120 degrees, the graph will recycle. What if you had that? Like cosine of 1/2 x. What's x going to have to get up to for you to go all the way around the unit circle? The x is going to have to go up to what? If it's multiplied by 1/2. To do 360 degrees, we're going to have an x of 720. And this is going to be then your period of y equals cosine of 1/2 x. If the multiplier on the angle is 1/2, you're going around the unit circle 1/2 as fast. It's going to take 720 degrees to recycle. The period is always the amount of time it takes to go around the unit circle. And the amount of time it takes to go around the unit circle is dependent upon the multiple that's in front of the angle. Now, what about in the general case? If you multiply by k, what is the x that's going to hit you there? In other words, what is your period? Well, it's always based off of 360, and it's basically divided by whatever k is. Because if k is 2, you go around this unit circle twice as fast, your period is down to 180. If k is 3, you're going around the unit circle 3 times as fast, your period is 120. If k is a half, you're going around the unit circle half as fast, your period is 720. But in general, whether you have y equals cosine of kx or y equals sine of kx, your period is always going to be 360 divided by k. So if you look at the period of your graph, you can know what the multiplier is on your angle. Example. Let me give you an example. Make sure we're doing it on time. Yep, we're doing great. So here's an example. This graph goes up to 8 and down to -4. This graph has a center line in the middle. This graph starts up at 8 and recycles itself every 180 degrees. Ooh, that's different, right? Normally the recycling is every 360 degrees. But this graph is recycling every 180 degrees. That's going to have an influence. So, first off, is this a sine or a cosine graph? Cosine, because we don't start at the origin, we start way up there. So this is a cosine graph. 2. Is this a positive cosine graph or a negative cosine graph? Positive, because it starts up, right? So it's a positive cosine graph. 3. What's the amplitude? How high are the peaks? How high is it from peak to center line? How high is it from center line down? You can look at that whole distance. The total distance is 12, which means the amplitude, 6. So you put all this together, you'd have y equals 6 cosine x, right? Oh, the center line. Is the center line at 0? No, sir. Where's that center line at? If the amplitude is 6. But yeah, the center line's at 2. Right? So that means everything's been up 2. Center line equals 2. That means everything has had 2 added to it. Now, the last thing that's different from what we used to look at, we used to look at cosine, positive or negative, amplitude, center line. We're going to add one thing to that, and that's period. What's the period? 180 degrees, which is 360 degrees divided by 2. If you can express the period as 360 over something, the something that 360 is over is the multiplier on your angle. So when I look at this, I see that 2 down there, and that tells me what my multiplier is. So that tells me I don't have y equals 6 cosine x, I have y equals 6 cosine 2x. This 2 becomes the multiplier of the angle. That will take you around the unit circle twice as fast. When x equals 180, you've already gone to cosine 360. And notice how that's reflected on the graph. X equals 180 is all the way around the unit circle. So we add an extra criteria to our criteria list already. Is the sine or cosine, is it positive or negative? What's the amplitude? What's the center line? What's the period? I'll grab an additional example so you can see that. Motion. Oh, here's the fun one. Top 12, bottom 8. Center line in between. Make sure I get this right. One, two. It goes around once. It goes around twice. It goes around 3 times. 360 degrees. And we're going to find the equation of this graph. The equation that would yield this graph. Now look at this here. We went around once, twice, 3 times in 360 degrees. So break 360 into 3's. This piece here is at 240, and this piece here is at 120. Do you follow that logic? If there's 3 cycles in 360 degrees, then each cycle is 120 degrees. That tells you your period. Right there, your period is 120 degrees. It's always best to express your period as 360 over k. That way you know your constant. The constant here is 3. You go through 3 cycles where you normally go through 1. So first, is this a sine or a cosine graph?
Sine.
Sine. Is it a positive sign or a negative sign? Positive because it goes up first. What's the amplitude of this? How big are the peaks? 2. Amplitude is 2 because the whole graph has a height of 4, which means each peak or valley is either 2 up or 2 down from the center line. Thus, where is the center line at? The center line is at 10. I'll emphasize the positive because that's a plus 10, right? It's up 10 units. And lastly, what's our period? Our period is 360 over 3. Our period is, well, we're going through 3 cycles every 360 degrees instead of just 1. Our period is 120. Let's take all this information and let's put it into an equation. Positive sine amplitude 2. That means we're multiplying by a positive 2. The period is 360 over 3. That means we have 3x. For our angle, that means we're going around the unit circle 3 times as fast. That means when x equals 120, we've gone around the unit circle, validated by the picture. And the center line's up 10, so we're going to add 10 to that. There it is, right there. So we have 2 times the sine of 3x plus 10. Plus 10 moves up the center line, 2 is the amplitude, 3 tells you about the period. Any questions on period changes? Any questions on changes in length of cycle? If you do have any additional questions, I would steer you strongly towards page 378 in the book. It has a nice diagram.
I just want a diagram.
It shows sine of 2 theta, which basically means every 180 degrees you have a cycle. It shows sine of 4 theta, which means every 90 degrees you have a cycle. It also shows sine of theta over 2, which means you're going around half as fast, where 720 degrees makes a cycle. The speed of your cycle is dependent upon the multiplier of your angle. And nothing else, in the case of the sine of those angles. Yeah, I mean, I'm glad that you can laugh about, like, I'm glad that you can laugh about characteristics of sine and cosine graphs, that's good, I guess. Okay, so from section 57, take a look at 8, take a look at 10, take a look at 11. Also, take a look at 15. 15 is a shading inequalities problem where they do not draw the graph for you. But the graph is a parabola in standard form and a line, so you can do that really easily.
Yay.
It's not going to take much effort. Because one of them looks like this, and you can graph that really easily. And one of them looks like this, and you can graph that really easily too. This is a parabola shifted right 2 and down 3. This is a line, oops. This is a line with a slope of -1 and a y-intercept of 1. You should be able to graph those pretty easily. Okay, good. We're going to go actually 15 through 21. And that's going to be it in addition to number 30. Sorry. I feel like that's
That's the other seven.
Sorry. I was watching Family Guy yesterday, and the doctor came
Yes.
in and said, "Sir, I'm afraid that you're not going to be able to walk again for the next 6 weeks while you have this cancer." So I kind of told the same joke. I'm sorry. Excuse my slick tongue there.